All right, team, this is notes number 8. So today we're talking about the difference between nonlinear and linear lines, and we can see some very similar equations, but they're a little bit different. The ones on this side are nonlinear, the ones on this side are linear. Right? The first thing that I would know is linear literally means line, and so we see this one here is a linear function. This one here is non-linear, makes like a curvy shape. Or just isn't a straight line. Could like this, could like that, could like this. It's just anything that's not a straight line, or a straight line down, or up and down, or flat like this. So in order to be a linear equation, the line should be straight, have no curves. So that's the first part. In order to be an equation, there's a few things. So in this one, it's nonlinear because it divides by a variable. So in order to be a linear equation, it cannot divide by a variable. Right? So because we see that divide by x here, it's not a variable. This one would be good. In this one, we see that the difference between the two equations here is that this one has an exponent. In order to be a linear equation, it's not allowed to have an exponent. So there are no exponents allowed. Unless it's a 1, of course. We could put x to the 1, but that'd be silly. No exponents allowed. Right? And then the last piece is that we see that this x times y is here. It means that we can't multiply two variables by each other. So no multiplying two variables. Right, so those are our rules. If we can multiply a number times a variable, we can do either variable too. It doesn't have to be x or y. This is allowed. We're just not allowed to multiply x times y. So we're going to look at some examples here. We're going to identify or state whether each is a linear or nonlinear equation, and then explain why. So in the first one, I'm going to look. I have 4 times x, that's allowed. I have 5 times y, that's allowed. And I have a number here, that's allowed. So we would say that this is a linear equation. And it asks us to explain, and I might explain by saying it doesn't break any rules. Break any rules. Right? For this one here, I would say that this is not a linear line. This is non-linear because it has an exponent of 2. An exponent of 2. I'll just draw an arrow right to it, so it's really obvious. Go ahead and take a look at the next two. In this one, we would say this is linear. It doesn't break any of the rules, so I can put that same thing here. And then this one I would say is non-linear because it multiplies two variables together. It multiplies two variables together. Alright, so not so good. Now we have the x and the y times each other. All that means is just that these are not going to be straight lines. So these ones here on this side will create lines. The first one would have a positive slope like that, and then the second one, this one here, would look something like that. This other one here is an x equals, so we know that it goes something like that. These ones here, they would be more of that curvy line that we saw from the past. This one is a parabola, just like that. So just like a couple tricks so you can know if your line is straight or curved. We're then going to move into some standard form, and this one can be a little tricky, and so I just make sure that you're plugging along, ask questions when you have them, because we're definitely going to have a lot of questions today. So standard form is ax plus by equals c. So we see a, b, and c are integers. That means that they have to be whole numbers, so non-decimals. No decimals or fractions are going to be allowed. Then they have a GCF of 1, so that means that we can't take anything out of them. A has to be greater than 1, so A cannot be negative. Right? And A and B are not allowed to be 0. So we can't have A or B be 0. So a lot of rules, and we're going to try to figure out how to make these equations fit those rules. So it says write each equation in standard form, identify A, B, and C. So first thing I see here is that this is a fraction, and it told me, we said up here that we couldn't have decimals or fractions. So I'm going to get rid of that fraction. I see that they're dividing by 10, so I'm going to get rid of it by multiplying both sides by 10. Right? So 10 times negative 3x would be, or over 10 would be negative 3x, like that, equals, and then 10 times 8 would be 80y, and 10 times 150 would be negative 150. I see here that a, x, and by, the x's and the y's need to be on the same side. So I'm going to move the 80 y's to the other side, just like that. So I'm going to have negative 3x minus 80y equals negative 150. So I have them all as whole numbers. I have the x and the y on the same side, but it tells me here that a cannot be negative. So I need to turn the negative into a positive. The way that I'm going to do that is I'm going to divide by negative 1. What I do to one side, I have to do to all the sides. So dividing by negative 1 will turn this into a positive 3x, a positive 80y, and a positive 150. So it actually turned everything into positive, which is pretty cool too. So I'm going to check. It says A, B, and C need to be integers, so no decimals. That's good. Checked off on that. It says a GCF of 1. That means that I can't factor anything out. There's nothing that goes into 3 and 80 and 150. So I'm not going to factor anything out. A is not allowed to be negative. A is positive in this case. And A and B are not allowed to be 0. So they're 3 and 80. So I know that it fits that rule as well. Right? So the last step is to identify A, B, and C. So I would say that A is 3. That comes from here. B is 80 from up there. And C is 150. Just like that. So this is here in standard form. That's my standard form. And then I have A equals 3, B equals 80, and C equals 150. Can be really tricky, guys, so let's try another one as well. So in this case, I know that I'm going to start by getting x and y on the same side. So here I have x and y, they're on the same side, but I need c to be on the other side. So I'm going to add 9 on both sides. I have 3x minus 6y equals 9. I see that 3, 6, and 9 all have something in common, and that is 3. So I'm going to divide by 3 for each piece. Right? So 3 divided by 3 is 1. I don't need to write it anymore. Minus 6 divided by 3 is 2 y's. And 9 divided by 3 is 3. Alright, so that's what they mean by GCF of 1 there. Right, so I've got to take things out if there's anything that I can take out. A, B, and C need to be integers, so no decimals. That's good. Did this one. GCF of 1, took that number out. a is not allowed to be negative, and it's not right now. It's right there. It's positive 1. And a and b are both not 0. So we did that as well. So we know that we have our standard form here. That's our standard form. And then we would say a equals 1 from right there. B equals negative 2 from right here. And C equals 3 from right there. If you put them in order, and they're in the right order, then labeling A, B, and C should be really, really easy. All right, take a breath. If you're feeling stressed out, that's okay. We're just going to do one more thing here. So we're going to practice this same skill, writing in standard form, and we're going to use it to find the x and y intercept. So first, I'm going to write this in standard form. So I'm going to take the 4 and move it over. I have negative 2x plus y equals 4. I remember that a is not allowed to be negative, so I'm going to divide by negative 1. Negative 1. That's going to give me 2x minus y equals negative 4. Right, so I have my standard form is right here, standard form. And then it tells us here that in order to find the y-intercept, we set x equal to 0, and then we solve for y. So in this case, I'm going to set my x to be 0. X is turning into 0. I'm subtracting y, should be equal to negative 4. 2 times 0 is 0, so I don't need to write it. Negative y equals negative 4. Divide both sides by negative 1 to get rid of the negative. And I'm going to have y equals 4. And remember we said that x was 0, so I would say that this is 0, comma 4, where my x is 0 and my y is 4. My x is 0, y is 4. So I can plot that first point on my graph. That would be 0, comma 4. You're right up here. Right? So that's my y-intercept. My x-intercept, we set y equal to 0 this time, and I solve for x. So I'm going to take this same equation, 2x minus y equals negative 4. I'm going to set y equal to 0, so it says 2x minus 0 equals negative 4. Minus 0 I don't need to write anymore, so I'm going to write 2x equals negative 4. Divide both sides by 2 to get x by itself. X equals negative 2. Remember that I put in my x is negative 2 and that y is 0, right? Because that's what I put in to find it. So I'm going to go to that point, negative 2, comma 0. Now that I have 2 points, I can go ahead and draw a line straight through there. Right? So I can see that this goes like this. I can try to extend both directions. It doesn't have to be exact, but I go slowly, so it looks pretty close. And then this is the graph of this line here. If I've got Desmos available for me, I can go ahead and type in that equation. So the equation is negative 2x plus y minus 4 equals 0. I can see that line there, and it's exactly the same as the blue line that I drew on here, and so I know that I graphed it correctly. And that's how we graph using the x and y intercepts. All right, please ask questions, y'all. This is a different